This course is divided into 10 different modules. In module 1, we will discuss about Teradata introduction, where we discuss about what are the advantages Teradata has, and then we will discuss about the difference between OLTP versus data warehouse applications, and then we will discuss about various tools and utilities provided by Teradata. And then at the end of module 1, we will discuss about how do we install Teradata software in your personal laptop. Okay, so we will take a Teradata 14 version, and then I will explain the steps whatever is required to install Teradata and then corresponding utilities. Okay, and then in module 2, we will discuss about Teradata architecture. Here we will discuss about the components involved in Teradata architecture, and then how data is stored and retrieved from Teradata whenever you run the SQL. Because the main thing with the Teradata is, right, like whenever you run any SQL queries, right, you need to understand how the data is inserted or retrieved from the disk. Okay, so understanding this will help you to tune your queries. Okay, and then mainly the Teradata, it's based on the architecture called MPP architecture. It's nothing but massively parallel processing architecture. We will discuss like how the parallelism architecture works with the Teradata. Okay, and then in module 3, we will discuss about SQL functions. Since you have worked with Oracle, right? So this should be, I mean, it's the same as Oracle. Like we will discuss about various DDL statements, DML statements, and then other logical operators and string manipulation function. 80% of these SQL queries, it will be same as Oracle. So, okay, so it won't be hard for you to go through this one. So we will try to quickly cover this SQL part. Okay. In module 4, we will discuss about Teradata indexing concepts. This is a critical part of this training, and because in Teradata the indexing is very critical, because based on the indexing only the performance will improve. Okay, because even the data distribution or data retrieval, everything is based on the index whatever you are defining for your tables. Okay, so we will discuss about various indexing concepts, like what is primary index, how primary index is related with your with the performance of the query. Okay, so and then we discuss about secondary index and how it is helping to improve the performance of the queries. Okay, and then we'll discuss about partition primary index as well. And then in module 5, we will discuss about various Teradata objects, like what are the types of tables we have in Teradata, and then we'll discuss about how do we create views, macros, store procedures, and join index. Join index is nothing but I think in Oracle we use the term materialized view, something like that. Okay, so it's similar to materialized view in Oracle. Okay, and then we will discuss about various space concepts, because when you work in a real-time project, right, like most of the time whenever you run any queries which involve large volume of data, mostly you get some space errors. Okay, if you understand this space concept, then based on that you can tune your query to avoid space errors. Okay, and then in module 6, we'll discuss about advanced SQL concepts. Like here we will discuss about overlap functions, like whatever functionalities you can achieve using overlap concepts, right? So here in Teradata they have introduced some functions which will simplify your query to achieve whatever functionality can be achieved by using overlap functions. Okay, and then we will discuss about compression concepts. Compression also, it's very critical in Teradata, because when you handle with a large volume of data, right, the size of the table will be huge. Okay, if you understand the compression concepts, you can apply compression on any table to reduce the size of the table. Okay, because when you reduce the size of the table, not only the space, it will improve your IO also. Because so we'll discuss about how we can apply compression and how it will improve the performance of your queries. Okay, and then we will discuss about collect statistics functions, like because the performance of all the queries, it's based on the statistics available for that particular table. Okay, we will discuss about how can we collect statistics on the table, and then in which scenario we can collect statistics, and then how collect statistics is used to improve the performance of your queries. Okay, And then we will discuss about various DBC tables. Mainly the DBC tables, it's nothing but data dictionary tables. Most of the time they will be used by DBS, but still there are some setup tables which will be frequently used by Teradata developers and designers. Okay. Moreover, we use some setup DBC tables to understand the query runtime, and based on that, we will improve the performance of the queries. Okay. So we'll discuss about some DBC tables which will be required for developers. Okay. And then in module 7, we'll discuss about various utilities provided by Teradata, like how do we import data into Teradata tables, and then how do we export data from Teradata tables. Okay, there are a set of utilities provided by Teradata, like a fast load, multi-load, BTEC, and fast export. We will see what is the use of each of these utilities, and then we will go through some examples to either load or export data using these utilities, and then we'll discuss about the scenarios like when you can go for these utilities. For example, right, if you want to load the data into Teradata, either you can go for fast load, multi-load, even you can use BTEC to load the data into Teradata tables, and then you can use TPT as well. Okay, we'll discuss about scenarios, in which scenario you can use fast load and when you can go for multi-load. Okay, so we will discuss about various scenarios. Okay, and then in module 8, it's mainly theoretical concepts. Here we will discuss about how the data is protected in Teradata. Okay, because in any environment there are possibility of software and hardware failures. So here we will discuss about how Teradata protects the data from any hardware or software failures, because most of the hardware or software failures are handled automatically by Teradata. So we will discuss about various failures and then how Teradata recovers from those failures. Either it could be a networking issue or it could be a disk drive failure. So we'll discuss how Teradata recovers from those failures. Okay. And then in module 9, we'll discuss about performance tuning concepts. Here we will discuss about how Teradata, what are the strategies Teradata uses for joining the tables, and then how we can apply various tuning techniques to improve the performance of the queries. Okay. And then the last module 10, it's mainly to cover basic interview questions, and then real-time scenarios like what are the activities that a basic Teradata developer or designer do in any project. Okay, so we will discuss about some real-time scenarios. Okay, so that's about the course contents. Okay, so before we go further, is this in line with your expectation, or you're looking for something else as well?
Yeah, Sundar, basically I have few more questions with you. Like in indexes, can you go to that page, index 1? Yeah. Index in Teradata, do we have primary and secondary partition? Primary, that's all. It means like Oracle, we have multiple different types of indexes based on the data storage. We don't have the same thing in Teradata, or
no, when you say, Oracle specific, like what are the indexes you are referring to?
Like, for example, hash indexing is required for different kind of data. Suppose if we have incremental kind of data, then we are using normal index. Suppose if we have a repeating kind of values, then we are using bitmap index. So, means index and Oracle changes as per the nature of data. Okay. So, how we can handle those things in Teradata?
So here, right, the indexing, mainly the primary index, it's a mandatory one for any Teradata table. Okay, so based on primary index, Teradata will distribute the data. Okay, for example, right, let me show this slide. Okay. So this is the high-level Teradata architecture. Okay, whenever you buy any Teradata system from Teradata Corporation, right, we call it as a node. Okay. In each of the node, there are majorly 3 components. Okay. For example, right here I have parsing engine, message parsing layer, and AMP. AMP is nothing but access module processor. Below that you have set of disk. Okay. For example, right, if I say that I have a Teradata system with 40 GB capacity. Okay. When you buy the system from Teradata, they configure the number of amps in the system. Okay. In this case, the number of amps is 4. Okay. Since I have 40 GB capacity in my Teradata system, The 40 GB will be divided by number of amps here. So each amp will have 10 GB capacity. Okay. Whenever you insert any data, right? For example, you have an employee table.
Yeah.
You are trying to insert 10,000 rows. Okay. So all the 10,000 rows will be divided equally between all the amps. Okay. So amp 1 will own 2,500 rows. Okay. Amp 2 will own 2,500. So the data will be distributed between all the amps. Okay. So the distribution is mainly based on primary index. Okay. Whenever you create any table, so you have to, primary index is mandatory. You have to define one column as primary index. Primary index is different from primary key. Okay. Primary key is, it's nothing but it's a logical term. Whereas in the primary, in the case of Teradata, right, primary key is optional, but each and every table should have one column as primary index. Okay. Based on primary index only, Teradata will decide which amp gets which row. Okay. Why it's required is, whenever you, for example, right, when I insert 10,000 rows into this table, right, all the 10,000 rows will be divided between all the amps. Okay. So each amp will insert 2,500 rows. Okay. This processing will run in parallel. Okay. For example, if you assume that, right, inserting one row takes 1 second time. Okay. In the normal process, the inserting 10,000 rows will take 10,000 seconds. Okay. But in this case, right, the data will be divided equally between all the amps. Okay. So each amp will take 2,500 seconds to insert the data. So instead of taking 10,000 seconds to insert all the 10,000 rows, here the entire insert operation will complete within 2,500 seconds, because each amp will run in parallel to insert the data. But the distribution is based on primary index. Okay. Primary index is the one which will decide which row goes to which amp. Okay. So that's why primary index is critical in Teradata. Similarly, right, when I run select star from, when I run a query like a select star from employee, right, the request will go to all the amps. All the amps will fetch the data from their corresponding disk. Okay. So instead of taking 10,000 seconds to fetch the data, within 2,500 seconds, the amps will fetch the corresponding 2,500 rows of data, and then they will send it back to the client. Okay. So here we need primary index to evenly distribute the data. Okay. So that's where we use primary index. And then secondary index is sometimes, right, for example, I have employee table, any table, right, in a real-time environment. For example, right, I may have 100 or 200 columns also. Okay. But for primary index, I can define either one column, or it's not necessary that primary index should have only one column. Sometimes you can use a combination of columns. Okay. But still, there could be only one primary index. Okay. But sometimes, right, when you run any query using primary index, the query will run faster. But in real-time environment, right, for example, if you take customer table, right, some set of customer, for example, in the customer table, if you define your customer ID as primary index, right, whenever you run any query using customer ID, it will run faster. But sometimes there will be set of business user who will run the try to access the table using customer name. Okay. So in these cases, right, like secondary index is nothing but alternate way of accessing the data. Okay. For example, it's not necessary that the users will always use one set of columns to access the table, right? So in those cases, to improve the performance, we use secondary index. Partition primary index is, I think in Oracle also we have the partition concept, right? For example, if you have a huge table, we try to partition them by date, so that whenever we want to drop the table data for a particular date, right? So the delete query will run faster, right? Similar to that, we have this partition primary index, where mostly we use partition primary index for on any date column. For example, if I have a sales table, right, we normally try to partition that table based on the sales rate. So whenever we want to access the data for a particular month, right, so instead of accessing the entire table, we will try to access only that particular partition. Similarly, dropping the data also, it will run quicker, because you won't try to access each and every row. Instead, you go and directly delete the rows from a particular partition. Okay. So these are all the major concepts. But in addition to that, we have various indexes, like a hash index also we have, but mainly whenever we join the data, right? So in those cases, we have different joining strategies. Okay. We will discuss that in detail. But when it comes to index, these are all the three indexes we have. And then the join index is like Join index, it's similar to materialized view in Teradata in Oracle. Okay, so if you, to improve the performance, right? So we use the join index. Okay, so mainly when you say index, it's a primary index, secondary index, partition primary index, and join index. Okay, whatever table you create, everything based on your the volume of data or how you access the data, you will define one of these index. But primary index is mandatory, but secondary index, partition primary index, join index, they are optional. It may we add those indexes to improve the performance.
Okay, so basically, when we are creating any index, suppose, like for example, if we are creating the partition index, primary index, and let's say we have 10 records, and suppose 2 records in AMP1 and 2 in AMP2, and whatever the select criteria we are running, suppose the data is only in one of the AMP, so it will check the remaining AMP, or it will just based on the indexes, it will bring the data from the particular AMP.
So it based on primary index. Okay, for example, right, if you try to fetch the data using primary index, okay, for example, in my employee table, employee ID is my primary index. Okay, if you try to fetch the data using your employee ID, Teradata will know that in which AMP that particular, for example, right, you are writing a query saying that select star from employee where employee ID is 101. So here employee ID is primary index. Okay, in that case, Teradata will know in which AMP that employee ID 101 is stored. Okay, in that case, it will directly go and fetch the data from AMP 1. Okay, but for example, right, if you try to run any query based on any non-index column, for example, employee name, which is not a primary index. Okay, so you are writing a query like a select star from employee where employee name is Sundar. Okay, so in this case, Teradata, it doesn't know in which AMP that particular employee record is stored. Okay, in that case, it will send a request to all the AMPs. Okay, they will search, each AMP will search in their desk for any employee record with the employee name as Sundar. Okay, so in that case, all the AMPs will be used. Okay, so if you use primary index in your query, so only one AMP will be used. Other AMPs, the request won't be sent to the remaining AMPs. Okay, only one AMP will receive the request. But if you don't use a primary index in your query, the request will go to all the AMPs.
And the similar way, the partition one will work, right?
Yes, right.
Suppose the partition.
The primary index is the one which defines the data distribution. Okay, if you don't use primary index, then the request will go to all them except secondary index where only 2 AMPs will get the request. Okay, we will see that in detail. Whereas in the case of partition primary index, right? So within the AMP, how you want to sort the data? Okay, that if you define partition primary index within the AMP, for example, if you have 2,500 rows, right? By default, they will be sorted based on their type. So partition primary index, like for example, right? If you don't define partition primary index, the data will be within each AMP, data will be sorted based on the primary index value. But if you use partition primary index, data will be sorted based on whatever column you are defining as a partition primary index. For example, if you define sale data as a partition primary index, right? So within each AMP, the data will be sorted based on the sale date. Okay, so that whenever you try to fetch the data based on sale date, right? So you will access only one partition. Okay, so mainly the partition primary index is mainly to sort the data within the disk. Okay, we'll see some example. Okay, how the data will be sorted and how it will help to improve the performance. Okay, so we'll quickly go through on the advantages whatever Teradata is providing. Okay, so one of the main advantage of Teradata is its parallel processing capacity. Okay, so here I showed here, right? So whenever you run any kind of SQL query, right? So the architecture what Teradata using is this MPP architecture, massively parallel processing architecture. Okay, so the basic concept behind this MPP architecture is whatever task you are doing, right? Each and every task will be divided into several subtasks, which is nothing but a smaller task, and then each subtask will be run in parallel. Okay, so here in Teradata I explained, right? Whenever you try to insert the data will be divided evenly across all the AMPs, and then they will be inserted in parallel. Okay, so similarly when you try to fetch the data also, the request will go to all the AMPs. Okay, and then each AMP will fetch the data from the respective disk, and then they will send them back to the client. Okay, so each and every query, it's not only insert or select. Okay, either delete or any kind of query or any join, any kind of query you run against Teradata, they will be the workload will be divided evenly across all the amps. Okay, and then they will be run in parallel. Okay, in our training we will see in detail how the data is distributed across all the amps. Okay, how the join happens in each amp. Okay, so here the basic advantage of Teradata is the parallel processing capacity. Okay, so each and everything will be run in parallel, and moreover Teradata, it can support huge volume of data. So here you can start from few gigabytes of your data warehouse capacity, you can go to terabytes, and then now you can go to petabytes as well. Okay, so it can support huge volume of data. And the other advantage of Teradata is its linear scalability. For example, right, it's always common that when you start your data workers, you start with a smaller capacity. As your company grows, right, the volume of data also grows. Okay, then you try to increase the capacity of your data worker system. Okay, so when you want to increase the capacity of your data worker system, you buy additional nodes from Teradata. When you bring an additional node into Teradata, so we will see one example. Okay, for example, I have 40 GB system. Tomorrow I want to make it as 80 GB system. In that case, what will happen is, right, similar to this particular node, you are buying another node from Teradata. So that has 4 amps and then 4 disk. Okay, what will happen is when you add a new amp to the existing system, Teradata will redistribute the data, whatever is stored in these 4 amps, right? So it will automatically redistribute the data to the new 4 amps, whatever you are adding here. So your system will have 8 amps. The data will be distributed evenly across all the amps. Okay, we call it as linear scalability. Okay, so we will see in detail like how the scalability happens at the amp level and the disk level. But what I'm trying to say is, whenever you want to increase the networking capacity or storage capacity or processing capacity, right, you can just keep on adding additional amps or disk or nodes. Okay, so it's we call it as linear scalability. Okay, so it's the amount of work required to increase the capacity, right, it's very minimal here, because when you add the new node, right, Teradata will automatically redistribute the data to the remaining the new amps or disk. Okay, so we, in Teradata term, it's called as linear scalability. And
So
another yes,
I have one question. Can you go to previous screen?
yeah.
This amp and disk. Suppose I want to add few more amp. Basically, amp is a physical thing, or it's a metadata?
No, it's in a Teradata term, it's called it as virtual processor. You can assume that it's not a physical thing. It's another. You can just assume that it's a process running, or because in Teradata we call it as virtual processor. So
Okay.
it's not a physical thing.
Suppose when we are adding further amp, means we are adding virtual processor, and
Yes, right.
okay, so that all like this messaging passing layer. This is also a this is
No,
also
message passing layer. See, the passing engine and AMP, right? They are virtual processor. Okay, they are virtual. They are logical terms. Okay, whereas in the case of message passing layer, right, it's a both logical and a physical component. Okay, here you have logical this program process running, and similarly you have your hardware and software associated with this. For example, right, when you say message passing layer, another term you use it, BiNet. Okay, so BiNet, this message passing layer, it acts as a networking layer between your passing engine and AMP. For example, right, if you add additional node, right, so it's again used to connect different nodes. That is using your physical cable, right? You connect different nodes. Okay, there it acts as a physical layer. Okay, so this message passing layer is both it consists of both logical and physical components.
okay. Yeah, thank you.
So within the node level, it's acting as a communication layer between parsing engine and AMP. When you have multiple nodes between nodes as well, it acts as the communication layer,
Okay.
where you physically connect each and every node using cables.
Yeah.
Okay. And another advantage of Teradata is it's a optimizer. Okay, optimizer is the one which whenever you run any SQL query, right, optimizer is the one which converts your SQL query into set of execution steps. Whereas in the case of Teradata, right, the optimizer, it's in the market for more than 20 years. Okay, so it went through a lot of revisions. So it's in the market. It's one of the most matured optimizer. Okay, and then when it comes to connectivity, right, so you can connect to Teradata either from mainframe or your network-based system. Okay, for example, from mainframe, you can connect to Teradata and then you can run all your SQL queries. Similarly, from a Windows-based system, you can connect to Teradata. Similarly, from a Linux or a Unix-based system, you can connect to Teradata. Okay, so it can, from any environment, you can connect to Teradata. Okay, and then SQL support. So whatever SQL you use either with the DB2 or Oracle, right, everything can be used with the Teradata. In addition to that, Teradata, it provides its own extension. Okay, we will see that what are the extensions provided by Teradata. But most of the, almost I would say that 90% of the SQL, whatever you use with the Teradata or I mean the DB2 or Oracle, right, they can be used with Teradata as well. And then the fault tolerance, there is a separate module to cover this. So any software or hardware failure is happening, right? Teradata has the ability to recover from failures. Okay. So here, in one of the module, we will discuss about what will happen if this particular RAM goes down. How do we recover the data associated with this particular disk? Okay. And then if the disk drive fails, right, how do we recover the data? Okay. So most of the things, whenever the RAM goes down, right, Teradata, you don't have to do much of the things because Teradata will automatically recover the data from the failed RAMs. Okay, so that's another advantage of Teradata, the ability to recover from failures. Okay, and then low maintenance because the activities the DBA has to do for Teradata-based system, right? It's minimal compared to any other RDBMS software. And the another advantage of Teradata is the utilities provided by Teradata, the fast load utility or multi-load utility or export utility. They are more popular or robust utilities in the market because in no time they can export or import large volume of data into Teradata. Whereas in this case of TPT, right, it's the latest addition by Teradata. Earlier, we used to call them as standalone utilities. For example, if you want to load the data, either you have to use fast load or multi-load. If you want to run any kind of queries, you have to use BTEC. If you want to export data, we used to write a fast export scripts. Now in TPT, instead of each of these utilities have their own scripting language. So now Teradata is trying to replace these utilities. So in TPT, whatever functionalities these utilities are providing, like fast load, multi-load, BTEC or fast export, right, everything can be achieved by TPT. Another advantage of TPT is you need to understand only one scripting language to perform all these functions. Okay, so but already these utilities are popular across all the customers. Okay, so whenever you go to any customer environment, right, most of the scripts are in these utilities only. Okay, the TPT is a new thing, so it will take some time to become popular. But in some customer environments, whatever new load or export scripts they are writing, right, they are preferring TPT. But already there are existing scripts which are written using these standalone utilities. Okay, but Teradata has announced that going forward they won't be adding any additional features to these standalone utilities. Okay, any new feature will be introduced only for TPT. Okay, so for each of these utilities we will see some example. Okay, so it's about Teradata advantages. What are the advantages Teradata provides compared to other RDBMS systems? Okay. Okay, this one we have already discussed. So what are the utilities Teradata has? We will see some scenarios like when we can go for these utilities. Okay, for example, right, fast load we mainly use to load staging tables. Okay, for example, if you want to load large volumes of data into an empty table, you can go for fast load. Okay, only constraint of fast load is the target table should be empty. So that's why in any customer environment we use fast load to load staging tables. Whereas in the case of multi-load, the target table can be empty table or it can have data. So using multi-load, either you can load the data or you can update the data, or you can delete the data. Okay. In addition to that, for example, if you go for BTech, right? BTech is nothing but a batch or interactive communication utility. For example, if you want to run any kind of queries, right? You want to create a table, or you want to run any SQL queries, or you want to run macros or store procedure. Anything can be done using BTech. Okay. And fast export, if you want to export large volume of data from your Teradata data warehouse, you can go for fast export. And then we have a utility called a TPUM. If you want to move data continuously into your Teradata system, right, you can go for TPUM. The difference between TPUM and the other utilities, like when you use fast load or multi-load, right, the target table will be locked until the data is loaded. Whereas in the case of TPUM, the table won't be locked. Okay, so only the row, the lock will be placed only at the row level. Okay, so for example, if you want to load data continuously into tables, and each and every time you will load only small volume of data, right? So in that case, you can go for a TPUM utility. TPT utility. So whatever functionalities, all this utility, all the 5 utilities are providing, right? Anything, everything can be achieved using TPT. So it's a single scripting language which will provide all the functionalities provided by these standalone utilities. Okay, but it's not that much popular compared to these standalone utilities. Okay. So that's about Teradata utilities. Okay.